No, no, it's fine. I believe you. I believe you.
I made it.
Sir,
Yes.
do you get salary from YouTube?
I don't.
Because you post video every day. Like,
Yeah, I know. I know.
I didn't used to put ads.
That's. I mean, yeah. Yeah, yeah.
Please don't pull ads.
No, I will not.
Please.
I could sponsor the videos. I could have, like, at the start of the video, first a word from our sponsors. You know, Casio calculator. Our word from Casio calculator. Yeah. Okay. Yeah. Candy Crush Saga or something.
or you can promote DISC.
Yeah, that's such a.
And
Right, okay, so have you got this one here? 94, question 10. It's a Venn diagram. It's a little bit tricky. So the situation is there's actually 3 sets. We have, what have we got? Math students, physics, and history, isn't it? Now, the trick with these, David, is it's easiest to start with the center, which means it's easiest to read this backwards. So the last piece of information I gave you was 1 student studies maths, physics, and history.
Yep.
So that's 1 here.
Yeah.
2 students study physics and history. Physics and history. So what do I put here? 1. 2 students study maths and history. So here?
Yeah. No.
1.
Yeah.
2 students study maths and physics. 1 there, yeah. Is that right? Yeah. 5 students study physics, and 4 students study history. 5 students study maths, and there's 11 students in total. It's at 5. 3, 1, 1, 1.
6. That's 6.
That's it.
Oh, it sure is, isn't it? Two. Okay. 11. Yep. Okay, there we go. Right, that's it really answered. Yep.
I just want to make sure about something.
Go on.
You put 1 between history and math because
Between history and maths.
yeah, because 1 student studied them all.
Yeah. You mean this one here?
Yeah.
Yeah, that was the last piece of information. 1 student studies maths, physics, and history.
Yeah, that's why you put
That one there, yeah.
no.
And this one?
Yeah, you put 1 because
It's a 2 students study maths and history.
yeah, so 1 study all.
Yeah, that was counted. So then this one must be a 1 then, yeah. Okay, is that one okay? So the answer actually there's a typo here. The answers for A, B, C, D, E, and F. B should have been 2, and D should have been 2. If you want to correct that. Yeah, those answers for B and D should be 2, not 1. Okay, what do we need to see next? It's okay, yeah. David? Be careful, Brad.
I felt that.
Yeah.
Oh dear.
Ray, take a leave tomorrow.
My ball.
Yeah, I might not see you tomorrow, huh?
Oh yeah, no, I will. I must attend now.
No.
My attendance is so low, so yeah. I have to go to school.
Now, okay, what else do we need to see?
Big 1 was 6.
Yeah.
Which one?
17.
We did this one. No, we did this one. On 116. We did. Alright, we'll do it again.
No.
Oh yeah, we did
No.
Do you remember it?
Yeah, well, I did.
The last question on page 116. So, there is a security hole in most routers. The WPA password can be broken if the WPS pin can be guessed. Okay. The pin is 8 digits long.
We did?
One, I know, we're doing it again.
Yeah, I don't remember.
6,
When I thought I
7.
saw it.
Well, okay. So here's your chance to do it again. So the pin is 8 digits long. However, the last digit is what's called the checksum digit, which means it must be a certain value. So it's not really a choice. In other words, the last digit you actually don't have a choice about. So whatever these other 7 digits are, that determines the last digit. So there's only one choice here. Now, an odd bug is that the router tells you when the first 4 digits are correct, even if the other 4 are wrong. So you can break the task up into 2 jobs. The first job is to get the first 4 digits right. Then once that's right, it's finished and you move on to the second job, which is to get the next 3 digits right. Now, how many possibilities do we have here to try? We have 10
4.
and 10, 10 and 10. So that is 10,000, isn't it?
Yeah.
How many possibilities here? 10, 10, 10,
1,000.
1,000. Okay. Now, the combination here, this is one job followed by another job. So it's like you try to crack this, there's 10,000 possibilities to try, and then you try these 1,000.
Yeah.
So it's a plus
It's a
here.
plus, yeah.
So that's 11,000 to try. Now, if you can try 1 pin per second, which I think it's a reasonable number, then this will take 183 minutes. This many seconds is 183 minutes. Okay? Now come on, focus now.
Okay, sorry.
And that's it. Now, will it take you 183 minutes? That's the worst possibility. That's if literally the last pin is the correct pin. It could theoretically take you 1 second, because it could be the first pin you try. So on average, it will take half this time.
So 19.
So about an hour and a half to figure it out then. Okay. So yeah, this is, this one is okay now, I think. Right, what's next now? Have you done any combinations or permutations? Like Colin said you did a little bit in biology. He mentioned the words permutation and combination.
Yeah.
Really?
Really?
Yeah.
Really, on the same day I mentioned it.
Yeah.
He probably said it like he went deep into it.
No, he didn't say that. I just wanted to know
Yeah.
if it came up as a calculation.
Nah, it was more combinations of genes in relation to
Oh.
hereditary and
Yeah.
all that.
Combination of codon.
Did you have to calculate any?
No.
No.
No,
They put on a computer.
It was just the 4N.
it's just
Oh.
Wow.
Yeah, what was that one?
Yeah.
The elections.
Oh, because each one has a choice of 4,
Yeah.
and there's a string of n of them.
Yeah.
So that's at most 4 power n. Yeah, okay, because that's 4
Yeah.
times 4 times 4 times 4. But is each one a free choice?
No.
No.
There's restrictions, is
Yeah.
there?
Yeah. 3.
No restriction.
4N.
Like, I mean, I suppose my question is it theoretically possible to observe any combination of 4 letters? Or is there some combinations where you can never observe them? Like, I'll just make up an example, I don't know, but maybe it's impossible to see G for some reason or something, you know?
No,
everything is possible.
Every possibility, okay, so it really is a 4 power n choice then.
Yeah,
Yeah.
but that possibility have similar, yeah, like similar attributes. Like
There's some possibilities that they look different on the code, but they do the same thing, is it? Yeah, okay.
Oh.
Exactly.
Yeah.
Yeah.
Like G and GGU is the same.
It's just the same thing.
In the books.
Wow.
Okay.
So good.
The class, Kirill, it seems the class is impressed by your ability to remember 3 letters. Congratulations on being the top of the class. On your ability to do that. Okay, so there hasn't been any interesting calculation then in biology just yet then. And what are you doing? Are you doing genetics at the moment or not?
No.
Translation. We're looking at translation and transcription, current translation.
Oh, of the GATC
Yeah.
stuff then?
Yeah.
Okay, but it hasn't produced any calculations yet then?
No.
No, okay. Right, what else do we need to see here now? The last lesson we were doing was expectation and variance. No, it wasn't. It was those binomial questions. Yeah, yeah, I just want I think, I don't know which lesson was harder, because we had 2 lessons on binomials, so what would we need to see? The second lesson.
Yeah.
Okay, well, just as a practice, now you need the formula book open. We'll just look at the last question on 128 as another practice one here. Okay, a pin code is made of 4.
What's your question?
The last question on page 128.
Yeah, I've been good.
Yeah, a pin code is made of 4 digits, random digits. What is the probability of seeing a pin code with at least 1 0 in it? Okay, so first we have to change this into a binomial problem. What is the n here? 4, yeah. Now we have to think really carefully here about what a success and what a failure is.
Yeah.
So a success is seeing the 0
1 time.
and 1/10, yeah.
Yeah. 9 times 1 time.
So we're counting a success as seeing the 0.
Okay.
So in other words, each one of the
Yeah,
thank you.
yeah.
Each one of these could be 0 or a number which is not 0. Because remember with binomial we said we have to reduce the problem to a choice of 2. We can't keep it as 10 digits. So we're rephrasing this problem. The digits could be 0 or not 0. Getting a 0 is a success. It's like getting a heads. And then getting a non-zero is like a failure. It's like getting the tails. Okay. Now, we've seen this one in the previous lesson. The probability of at least 1 success. How do we recast that? No.
3 or less.
No. We change this into 1 minus
Oh,
the
1
probability
minus
of not
not. Yeah.
Getting 0.
at least 1,
Not
which
is
means,
one,
yeah, as you said, Kirill, getting 0 successes.
yeah.
Yeah. So, according to our formula, that would be 1 minus. Now, actually, we don't have to use the form.
Yeah,
we
don't
can
need
use
to
we can
use
use the formula book as well.
But it doesn't have 5. It doesn't have 4.
Hmm? Oh, is 4 not in it?
No.
Okay, so we'll have to use the formula then. 4C 0, 1/10, 0, 9/10, 4. Yeah. And this works out, I guess, to be 0.3439.
Why did you put the B for like B is 1 over 10?
Yeah, so you have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I only care about getting 0, or not 0.
Yeah.
So if I have 10 numbers, and I'm picking one of the numbers, what's my chances of getting the number 0? Is 1 in 10. And not getting 0?
No, but the n is what shouldn't it be 1 over 4.
N is
four
the-
random.
Yeah. N is the number of tries,
Yeah, twice.
number of attempts, number of
But how
tries.
do you know they meant like from 1 to 10, not like from 1
Oh,
to
0 to 9. the word, you see, digit, D-I-G-I-T-S. In English, digit only means 0 to 9. Yeah, really, yeah. You didn't know that? You should write that down.
It's like a band code.
Yeah, like a pin code.
Pin code.
Pin code, yeah.
I thought digits like with values, like.
Ah, yeah, okay, no, fair enough. Digit means 0 to 9, and then there is another word that means a digit or a letter. So like 0 to 9 and then A to Z. What would you call that? Does anyone know? So we said digit means 0 to 9 in English. And there's a word that could mean 0 to 9 or A to Z. What would you call that? If you had one of those. Almost like one of the buttons on the keyboard. You wouldn't call that a digit because you could have a letter. So, and you wouldn't call it a letter because you could have a digit. So what's the word that means it could be either? Yeah, but that's
symbol.
Yeah,
Symbol.
symbol is okay. Character. Character. Yeah.
Sir, is that the answer?
I don't know. Is it not this on the calculator?
I think it's 0.8.
Are you sure?
So let's
Yeah.
try.
Because it's
Nine over 4 is
probability of getting at least one, right? That should be high, right?
First is 0, 1. Whatever is
Probability at least
But did you type this in on the calculator
Yeah.
and you didn't get this number?
It's the same.
You did get this number?
Yeah.
Really?
Yes.
You're losing your credibility now. You were doing so well after your biology knowledge, and now it's just, I can plot it as a graph here, time and credibility, and it spiked up here with your biology remark, but now, right, it is this, yes?
Yeah.
Okay, fine. Now the B part, what is the probability of seeing at most 5 such pins like this? So this is an example. Do you remember what I called this type of problem last time? It's a nested problem, because now this 4-digit problem is now being put into a larger problem. So what we're imagining is you have a group of 30 people, and each of them get a pin code, and you're counting the success as somebody's pin code containing the 0. What percentage of the class will have a pin code containing a 0? It's on the screen there. That's what this is, 34%. So I would know, actually, yeah, if everybody thinks about their ATM pin code for a moment, you don't have to tell me it, okay? 34% of you should have an ATM pin code that contains a 0. Does anyone want to tell me if theirs contains a 0?
No,
Yeah. 1, 2, 3, 4, 5. Okay. So, and how many is in the class? 1, 2, 3, 4, 5, 6. So 5 out of 11. So that's a little bit more on this occasion than the 34%. Yeah. So it checks out roughly. Now that I know that 0 is in it, I need to think of 3 more questions in the rest of the semester so I can figure out the digits.
Oh, so bad.
Yeah.
Wow. There's a formula.
Yes. Whose pin code is more than 5,000? You can put up your hand then. Yeah. Wait, does your pin code have a 5 in it?
No.
Okay. I'm narrowing down the possibilities. Right.
You're in trouble, man. We're in trouble.
I'd still have to get her card though. Okay, so the probability of at most 5 successes. Now, that's a fancy way of saying 5 or fewer. Now that's good because that's how it is in the table book, isn't it?
Yeah.
It's 5 or fewer. So we need to go to the table that has n equal 30, x equal to 5. Now, is there a p-value that is close to 0.3439?
Yeah.
Yeah. What's the closest one? There's a 3.5?
3.5.
Okay.
0.3 as well.
Yeah, well, we'll go with the 0.35 if there is one. Is there?
Yeah.
Yeah, so what value do you get for that? 30, 0.35 and 5. Nikita, do you have the formula book open?
0.0.
Yes, check, yeah.
0.0
How do you know?
233.
There's no answer.
Yes.
Oh, okay.
Oh, we got it. 35.
So,
Yeah. So that means
but you-
0.0233.
Yeah.
but it's not approximately 0.25.
say again?
But it's not approximately.
But it's very close to it. It's 0.3439.
So in cases like this, we're supposed to go.
Yeah, if this was an exam question, then here certainly they want you to use 0.35 because it's extremely close to it.
You know, see,
Yeah.
if it's in exam, we just want to approximately closer.
Yeah, like I mean, I have no issue here in the exam because if you were to round this off to 3 significant figures, what would you get? It'd be 0.344,
Oh,
wouldn't it? 0.344.
close.
And the formula book is 0.350. That's only a difference of 0.006. That's perfectly acceptable. And in fact, I don't even think if you were to calculate exactly, I doubt it would have any significant effect on this answer. So what you're saying here is it's very unlikely that there'll be at most 5 people. And you can see that already because in this class of only, 11 students?
Yeah.
I think we already had 5 people, didn't we?
Yeah.
So if we increase the class to 30, then it becomes very difficult to have only 5 or fewer people,
No.
you know? Yeah.
Yeah.
Okay, what else do we need to see now? Previous one? Yeah.
11, probably.
11 is very similar to what I just did because it's another example, Nikita, of the nested problem.
That's not me.
I would like to do probably.
In maths, nested problems are problems that are inside bigger problems. So, for example, in this one here, do you notice how kind of
Yeah.
I have to use this answer as the P for the next answer?
So it's like a
Progressively.
It is, but in a very special way because it means your problem is now inside of a bigger problem. I'll give you an example here just before we go on. Like, you see, if I had an equation like something like this, and then I had an equation like this, can you see that this problem is inside of this one?
Yeah.
Because this is a quadratic and this is a quadratic. It's actually the same quadratic.
Mm-hmm.
Yeah.
If I was to give it a different letter, you know, like y. Anyways, that's nesting, nested problems. Okay. Yep.
Can we do correlations then?
Yes.
Regression. 1, 1, 4.
Which
1, 1, 4.
Yeah, which question?
6.
6 has no calculations in it, which is fine. But it's a good one too. 5.
Next time.
Yeah, 5's a good one here. Now, page 114. Aziz, come on. Come on, Ray, come on.
Mm-hmm.
Now, number 5 here.
Okay.
This is a good example of a question that shows how flexible regression is. So previously, we learned that regression is useful for calculating a linear equation to help us relate 2 variables together. I can't remember what examples we did in class where we had, you know, an x and a y, like height and weight or something like this. Okay, but it's actually more flexible than that, which we can see in number 5. So we have a science student sorry, that's a typo. Actually, can I just attend to it? Yeah, preformed. It's like, it sounds like they manipulated the rats. Not preformed, but rather performed 10 experiments on 10 lab rats. The rats were fed caffeine supplements. Guys, come on, please. Now, this question here is very relevant for the medicine students because this is exactly the type of stuff you would be doing in any kind of lab research. You know, you have 10 rats and they were all fed caffeine supplements. And, oh yeah, Red Bull, yeah. And their number of hours of sleep was recorded. Okay, so you can see here you have caffeine consumed in milligrams and you can have hours slept in hours, obviously. I think this will be over a week or something like this, whatever it is. Calculate the correlation coefficient. Now, I need the calculator, but maybe just to keep things moving along, I'll just use Excel here to do the calculations, okay? So let me just open up Excel here. Now, before we continue, do you think there will be a correlation between the two? Would you think it'd be strong or would you think it'd be weak? I think strong. Now, which way around is the x and the y axis? What would seem like the thing that goes on the x and what would go on the y? Caffeine would go on the x and hours slept would go on the y. And what value of or would you expect? A positive or a negative value? Negative. Because as you increase the caffeine consumption, the hours should decrease. Okay, so what I'll do, I'll just copy over the values here. We're saying X is caffeine, isn't it?
Yeah.
So would you mind calling them out? 3.85 is the first one, is it? Yeah, the next one?
4.41.
Yep.
4.99.
Okay.
4.68.
68?
5.15.
Yep.
5.74.
74, yep.
5.56.
Yep.
4.91. 5.33.
Yep.
5.33.
And now the hours slept.
46.
Okay.
54.
Okay.
49.
Yep.
49.
Yep.
53.
Yep.
43. 43. 47. 44. 48.
Okay.
I have a question. How do you can determine like the x and this is x and this is y?
Now that's actually a science question. Have you heard the vocabulary dependent and independent?
Yeah.
So if you think about this experiment, which is the independent variable you're
I
changing?
guess the independent like the thing.
Yeah.
It's just like the thing that you can control.
Yeah, which in this experiment is what?
Is the caffeine.
Yeah, and that's the x.
Oh.
And then the response, the dependent variable, is what you measure in response, which is the hour slept, which is the y. Yeah? Okay. Now, in order to calculate it, we need to calculate a few things. So, I'll write them here. Just to be clear, that's capital S, X. And what's that one? Oh, actually, I'll need a bit more space. Sorry. Let me just delete that. Can everybody see okay? I'll just move that over a little bit.
Is it still recording?
Yeah, it's recording. Yeah. Okay. X, Y. Okay, I'll just write it here. Capital S, X. What's that one? Do you remember?
Yeah.
Sum of all the x's. So you would do this on your calculator, but I can do it quite quickly in Excel. I get this. I might also need capital S, Y, which is the sum of all the y's. What else might I need to calculate? X, Y, isn't it? So in order to do that, I'll need another column here. Yeah, X, Y. So X times, yeah, very good, thank you, Hazza. Okay, and copy that down, and then this is S, X, Y, which is not,
X plus
well, it's not X plus Y.
and the sum of x plus
Yeah, it's not these two multiplied. It should be the sum of
xy.
these guys here.
Yeah.
Okay, now that's the big S is calculated, and you can see in the formula. Oh, I should write down also what the n is. What's the n here? It's 10. Okay. What else will I need? I'll need to calculate small sx, small sy, and small sxy.
Yeah.
Now, I think those formulas were on the previous lesson, weren't they? Yeah. So,
The
small sx is equal to square root. Oh, I've missed one. There's one more I still need to get, isn't there? I also need sxx, don't I? Yeah. Sxx. So that here is x squared.
Yeah. Each one, right?
Each one squared, like that.
Okay. I understand.
Oh, by the way, guys, in the exam, they kind of expect and they're perfectly happy if students make tables like this to help with their calculation. Okay, so that's perfectly fine. Sum of x squared, yeah.
Do we need the y squared?
No, actually, it doesn't look like we need the y squared for this formula. We're okay. Yeah.
The last one is the same.
Which one?
Because 5.3.
Last two of x squared.
Yeah,
They are same.
because of the same x.
Yeah.
Okay, so, sorry, where was I? Here. Square root. What is it now? Let me see. Sxx, which is this one over 10, minus the average, which I haven't worked out, which is this one over 10 squared.
Where is it over 10?
I add up all the x's and divide by 10 to get the average. Yeah. And sy is similar, isn't it? It's square root. Oh, I told you a dirty lie. We do need SYY. Sorry, has it? Where will I? Okay, I'll stick it up the top here. SYY, which means I need y squared, which is y squared. There we go. Sum. All right, it's getting a bit crowded here. Sy equals square root sum of yy, which is that number, divided by 10, minus the average of y, which is the sum of the y divided by 10 squared.
From what?
Yep.
Wait, the formula of sy is square root sum of y.
Yeah, sum yy, syy over n minus y average squared.
Why is sy1?
It's the same formula as for x, you just swap the x with the y.
No, I mean, is it because of the two? Square, like,
Oh yeah, that's, wait, what are you asking me?
like y is yy.
Oh, y is just the way of writing y squared, because it'll be a little bit too small to put a square here. Syy means y squared, yeah. Okay, and then,
Could you please align the column to the right?
what? Align the what?
S, X, X, Y. So
Oh yeah, okay, I understand now. Now, happy?
Yeah.
And look, I'll even align these to the left.
Perfect.
Yeah, okay, nice. Yeah, okay. Right, Sxy. Sxy is equal to the sum of xy, which is this one, isn't it?
Yes.
Divided by 10, minus average x, which is this guy, divided by 10,
Times average y.
times average y, which is this guy.
You don't need to divide on to get the average.
Yeah, because I didn't actually work out the average separately, yeah. Right, that's that. So finally, the OR I can calculate using the formula Sxy over Sxsy. So that's this one over that times that one there.
Where's this formula?
But that's on the next page, or
114. It's on 115.
no, he's looking in the formula book, I think.
Yeah,
Page
no,
6.
You see it?
Page 6 and page 7.
You see it, has it? That, you have it? Okay. So, you remember that you said you thought that the value should be negative? It is negative here. Minus 0.43. So, strong, weak?
Weak.
I don't know, for biology experiment like this, I think that's pretty strong.
Isn't it when you just square it to get rid of the negative?
Yeah. Do I ask for the or squared? I think I just asked for the or.
Yeah.
But it would be fine, it would be normal enough anyways to square this, so what's that, 19% roughly?
Yeah.
About 19%.
It's gonna be the strong thing, right?
It's going to be what? It's for a biology experiment, yeah. This is fairly good. A conclusive result. So it would seem that caffeine obviously has some effect here. Now, the next question is, and this is something I think you would have done with column, it's believed that the log of the hours has a stronger linear relationship than the number of hours. Now, just before we go on, I'll explain what that means.
We need to see the graph, I guess.
Yeah. I won't draw the graph, but I'll just put an example here. We are imagining the graph is going straight down like this. Now, perhaps the relationship isn't as linear as we think it is. After all, it's probably, well, what do you think will happen as we increase the caffeine? It has to level off. The rat has to sleep at some point. It's not going to, it's going to be like this. Because I think what would happen is, at some point you give it so much caffeine it dies. So, I think it might level a bit. Yeah. So one way you can improve your accuracy, your research here, if we call this hours and we call this caffeine, rather than saying hours equals a linear formula of caffeine plus a constant. That's a linear formula. Instead, we might say that the log of the hours is equal to MC plus a constant. In other words, rather than saying the hours has a linear relationship with caffeine, maybe it's the log of the hours has a linear relationship with caffeine. So, the point here is, rather than plotting hours, you plot log hours. Now, this is the advantage of using Excel. I can replace all my my y's with log values. So instead of having 46 hours slept, I would have.
Why do you use the log?
I'll explain that now in a second. Log 46. Well, it doesn't matter which base you use. I think this might be using base 10, but I'll use base E. Okay.
Oh, E.
What?
So is
one
this
is
Elon?
You see it?
ln, yeah.
Okay.
Wait, the ln is base E?
Yeah?
Yeah.
Straight one. Wow.
Now, Haza was asking me, and this is actually important, why using log? So in biology, quite often it's observed that responses depend. Guys, come on, I'm giving you some. At some point in the future, listen, at some point in the future, you're going to be sitting in a science biology lecture, and the lecturer is going to make some remark about the use of log on your data, and you're going to be thinking, that sounds familiar, like somebody was trying to teach me this before. Who was it? Okay?
A YouTuber.
Yeah, some YouTuber. What was his channel again? Yeah. So listen, in biology, it's quite common that you'll find it's not the original value that changes in response, but the log of the value. I give you some examples. I think a good example, like, is with eyesight. Okay, so you might respond how well people can see in the dark, and you obviously would reckon if you reduce the light by 50%, then maybe you reduce how well they can see by 50%. If you were to give them some kind of eye test, right? So you think the relationship is linear, but it would turn out that it's not their score on the test that's linear with the amount of light, but the log of their score. So imagine you give them an eye test and they get a score out of 100. Okay? And you think, oh, if I reduce the light by 50%, maybe their score halves. Their score doesn't halve, but the log of their score halves. So if you get the log of their old score and the log of their new score, you'll see that those values will halve. In other words, it's always worth trying to log your values and seeing if that gives you a better correlation. So rather than saying it's the hours slept that change, we'll say it's the log of the hours slept. So what I've done is I've replaced the hours slept with the log of the hours. So when you give the rat 3.85 milligrams of caffeine, how many log hours did they sleep? They slept 3.8 log hours, for example. And when you give the rat 5.33 milligrams of caffeine, how many log hours did they sleep? 3.871 log hours. Now, the formula has updated for me. What is the R squared now? It's now a full percentage point higher. I think previously it was 0.189, and now it's 0.199. That's one extra percentage point. So the model log hours is a better model than just hours. Okay? So whenever you're doing research, it is worth seeing if you can get better correlations by logging the values, especially if it's a biological measurement like hours slept, performance of eyesight, things like this. Yeah?
Do we log which value, like X or Y?
It depends on it's usually the Y, but you're usually logging the biological response. So obviously milligrams of caffeine isn't biological, that's like a chemistry amount, But hours slept, that's a biological response. So it's worth logging that, Is there any other things you've done in biology, like responses? Hours slept is an obvious one, but I don't know, like blood pressure or something like this. Yeah, maybe blood sugar, that could be a good example. You might be looking at patients' blood sugar response to some new diabetes medicine.
Also starch.
Yeah. Yeah.
Sir, how about one dividing the values? One dividing.
Oh no. Oh yeah, I talked to Colin about this. I don't like this. Yeah, I know exactly what you're talking about. This is where you take your values and you do 1 over.
Yeah.
Yeah. And did he explain why?
No.
Ask him. Ask him why.
Okay.
You won't get a good answer out of him, I promise you.
It's usually used in physics, right?
No.
No?
Ask him why you do that. You won't get a good answer. You'll get something like, oh well.
Alright, teacher.
Yeah.
So log could be used to save the actual value in case of transferring the model.
Yeah, it's like transferring the model. So rather than the actual value, you use log of the value.
Why you do this? Like you get
It improves the performance of the model. You get a better correlation.
As well as in other examples, you use log in order to not to damage the value, the number.
Yeah, well the nice thing about log is you can recover the previous value. You haven't lost it, you've just manipulated it, but it's not gone. You can get it back by using the E function.
Alright, could you please go back to the without log? So,
Without?
yeah, just
Oh,
press.
Okay. Okay, I think, hang on, one more should do it. Wait.
What?
Oh, come on, my error. What?
Why is it error?
That's why.
Change only one.
Yeah, what's gone wrong?
What happened to
I will just go.
Well, anyways, it's recorded, so you'll have to get it from the video then. Okay. All right. So, anyways, remember, log could be useful for manipulating the data to make it perform better for correlation.
We only use it for biological data.
Yeah, that's not only biological, but that is certainly where it's most common. So many biological responses depend on the log of the value rather than the value itself. I think you even see it in chemistry as well, David, in pH. Yeah.
Which minute of recording is it?
Right now it's at 45. So probably about 40, 39, yeah.